find limit using the limit laws. Okay. For that, in order for this two-sided limit here exists as a real number L, that limit exists if and only if the left-hand limit and right-hand limit equal to each other and both equal. Here's one example. We're trying to find this limit here as x approaching to 0. We know the function absolute value of x. The graph is going to be V-shaped like this, okay? And when x is greater than or equal to 0, absolute value of a number that's greater than or equal to 0 will be equal to that number itself. So that will be just equal to x. So on this side, it's just y equal to x. So it will be this way right here. Now what happens when x is less than 0? For example, when x is, say, -5, absolute value of -5 is equal to 5. Now x is -5. 5 here is opposite of -5. So absolute value of x is equal to opposite of x right here. So absolute value of x will be equal to opposite of x. When x is negative, opposite of x is positive. Okay. So on the left side over here, this is the graph for absolute value of x. Okay. So for example, when x is equal to -1, absolute value of x will be equal to 1. When x is -2, absolute value of x equal to 2. Okay. So that is the V shape for absolute value of x. So what's the left-hand limit of this function as x approaching to 0 from the left side? Well, as x approaching 0 from the left side, the function value is going to 0. So that's equal to 0. What about the right-hand limit? As x approaching 0 from the right side, the function value is getting closer and closer to 0 also. So the right-hand limit is equal to 0. So the left-hand limit and right-hand limit both equal to 0. So the two-sided limit here will be equal to 0. So that's equal to 0. Next example, the limit of this quotient. Well, over here, if you do direct substitution, you get 0 over 0, right? So whenever you see this involve this absolute value, and the absolute value of x is equal to 0 when x equals 0, and this 0 is this number right here. So if this number is exactly the number that make this absolute value equal to 0, then you need to consider limit from the left side and also the right side. Okay. So consider the limit as x approaching 0 from the left side. Okay. Absolute value of x when x is less than 0 is equal to opposite of x. So this will be opposite of x. Now, if you reduce this, negative x over x is -1. So that is -1. So the limit of -1 will be -1. So the left-hand limit is -1. Now, what about the right-hand limit? When x approaching 0 from the right side, then x is positive. When x is positive, then absolute value of x is equal to x itself. X over x is just a 1. So the right-hand limit here is a 1. So left-hand limit and right-hand limit, they don't agree. Therefore, this two-sided limit here does not exist. So does not exist. It's an answer over here. Okay, now this example. F of x equal to this when x is greater than 4 and equal to this when x is less than 4. And we're trying to find the limit as x approaching to 4. And you see this number 4 here? It's y at the border. It's y between this piece and this piece right here. So you will need to consider the left-hand limit and the right-hand limit. Okay, if that number is y in between these two pieces, then you need to consider the left-hand limit and right-hand limit. So let's think about the right-hand limit first. When x approaching 4 from the right side, which means x is going to be greater than 4. So for x greater than 4, f of x is equal to square root of x minus 4. Therefore, we will choose the first piece, square root of x minus 4. Do a direct substitution here, the result will be 0. So the right-hand limit equal to 0. Now what about the left-hand limit? When x approaching 4 from the left side, that means x is less than 4. For x is less than 4, f of x equal to 8 minus 2x. So we're going to choose the second piece, 8 minus 2x, for f of x. Now do a direct substitution here. We also got 0 because the right-hand limit and left-hand limit, they both equal to 0. So the two-sided limit here is equal to 0. Now if you graph this, this is going to be this piece right here. F of x equals square root of this is this piece right here. And f of x equal this is this left piece right here. And there is a gap right here. But when x approaching to 4 from the left, function goes to 0. When x approaching to 4 from the right side, function value also going to 0. So the two-sided limit here will be 0. Okay. Next one, we're going to talk about the greatest integer function. So the greatest integer function, what are integers? Integer will have 0, plus or minus 1, plus minus 2, plus minus 3, etc. Those are called integer. Okay. The greatest integer function, this is the symbol for greatest integer. So it's a bracket, but with the double bar right here. Okay. So that stands for the greatest integer that is less than or equal to x. For example, the greatest integer that is less than or equal to 4.8. So we have 4.8 over here. What is the greatest integer less than or equal to 4.8? Well, if it's less than or equal to this number, so we'll go to the left side and see what will be the closest integer. We see that will be 4. So this answer here will be 4. The greatest integer less than or equal to pi will be 3. Greater integer less than or equal to 5. Now 5 is already an integer, so that will be equal to 5 itself. What about this? Square root of 2 is about 1.414. So if you go to the left side, the greatest integer that's less than or equal to 1.414 is going to be 1. What about this one? Negative 1/2. Negative 1/2 is between these two integers. So you have to go to the left side to find the integer that is closer to this number. So we see that it is going to be negative 1. So the answer here will be negative 1. If you graph this greatest integer function, you see the graph is going to be like this. Okay, so when x is an integer itself, that will be just equal to that integer. So when x is 0, x is 1, x is 2, then we'll just equal to x. Okay, so you have to sort it out here. Now what about 1.1, 1.2, 1.3, etc.? The greatest integer less than or equal to those will be just 1. So it will be horizontal, so like this. They all equal to 1, the value. But once you get to 2, all of a sudden it's going to jump to 2. Okay, going to jump to 2 here. And then 2.1, 2.2, or they all take on 2 as a function value. And then until you get to 3, and then you jump up and become 3. So this is going to be the graph for this greatest integer function. And sometimes we call that the floor function. And you can see those are the steps right here. And like the step, you go up, okay? What happened to this limit as x approaching to 2? Well, as x approaching to 2, here's 2 from the left side. The function value goes to 1, okay? What happened to the right-hand limit? When x is approaching 2 from the right side, the function value is going to be 2. So the right-hand limit will be 2. Left-hand limit and right-hand limit, they don't agree. So this two-side limit here does not exist. So it does not exist here.